Well, welcome everybody. Good morning or good afternoon, depending on where you are. And welcome to the third session of the 2019 Cliff Grads webinar series, Mitigating Climate Change Through Reduced Food Loss and Waste. As with the first two webinars, this particular webinar is designed to allow all of the Cliff Grad Fellows, the 5 of you who are on this call, to share your research and learn more about the science of low emissions development, but also to build some of your research and career skills and to get to know each other. So that part is the same. What's a bit different is that we're going to focus now on food loss and waste. Almost everyone on this call is also a presenter. And then with Jan Broeze's help, who leads the food loss and waste research program from Wageningen University for CCAFS, we're now going to also explore the option of doing a joint research project on food choice and food loss and waste at the Bali conference in October. So my name is Lini Wollenberg, I think you all know, and I'm the flagship leader for the low emissions development program of CCAFS. I'm going to just briefly now go through the agenda. See if I can get back and forth here. So I think everybody has seen this. We have 3 parts to the agenda. In the first hour, I'm going to give a brief introduction, and then Jan is going to talk about a calculator, a very cool calculator tool that he's been developing. Then we're going to move to Norah Machinjiri, to talk about aspergillus and its effects, well, to talk about soil amendment, soil carbon amendments, and its effect on aspergillus and the consequent effects, for example, on rot in cereal crops and on aflatoxins. And then Tabitha Nindi is going to talk about storage of crops. And both Norah and Tabitha are from Malawi. Then we're going to skip Laura Holguin, who's not able to join us today. And Jan is going to give is going to help facilitate an overall discussion on Norah and Tabitha's presentations. Then we'll take a 10-minute break. And in the second half, we're going to listen to Li Shui about her study on quantifying greenhouse gas emissions in China along the supply chain using an input-output analysis. And Xia Liang is going to give us is going to talk about the evidence base for mitigation of nitrous oxide specifically in reduced food loss and waste in China and Myanmar. And finally, Daniele Matzembacher is going to talk about the conditions in Brazil for reducing food loss and waste associated with the aesthetics of fruit. So we have a really nice, diverse array of presentations. And in that second half, Jan is also going to facilitate a discussion. And then we'll have a last 25 minutes where Jan will facilitate the planning for the Bali conference. We'll talk about both parts of the plan, the greenhouse gas footprint of the lunch diet choices, and also calculating food loss and waste for the conference. And just to remind you, there will be a session on August 6th to follow up on this. So this will just be the first part of the discussion. As with the previous webinars, for participating, please, actually, I'm going to ask if everybody can use their video now so we can see each other. That would be the ideal. I think we can do that. Can we, Juliana? Can we share our webcams? I should do it too.
Yes, except for we do have a few people. For example, Tabitha is in rural Malawi, so I don't know if her connection will support it.
Yeah, well, let's try it because we're a small enough group that I thought we could do something novel and try that. So if you're panicking right now because you're in your pajamas, you don't have to do it, but if you can do it, it would be great. So just wanted to give everybody a few minutes, and yeah. I need to be able to get into the webcam part myself. Let's see.
It's just, yeah, it's just the little webcam thing. And Lini, would it make sense for people to do it as they're speaking? So like we can see Jan now, and when it's Tabitha, oh, there she is.
I'd actually like everybody to join, but I can't get out of my Well, I can't get out of my presentation for some reason and into the chat.
So how about I will now change the presenter to Jan, and then
No, I got
are
it.
you done with your presentation?
I got it. I got it. Let's see.
Jeez.
Oh my gosh. Anyway. Yeah, it's going to take a while for me to do it, so I'll do it when I'm done. Okay, so I'm going to just keep going. But please join on your webcam if you can, and then we can all see each other, which will be terrific. So I'm going to give a few words of overview about the CGIAR. As you may know, the CGIAR is a network of 15 different centers around the world focused on the mission of food security and poverty alleviation. Norah, for example, is working with ICRISAT. So there are 15 centers, but then there's 70 regional offices and many partner organizations, and it's quite an extensive network. Then, oh, sorry, CCAFS. It's not going. Huh, I'm sorry about this. I can't get my presentation to do what it's supposed to do. Unfortunately, I've had this problem because I have a Mac, and the computer tech people have told me Mac doesn't deal well with GoToMeeting. So I'm just going to talk from my notes. Let's see. Just a second here. Can't get access to my. I think I got it now. Yeah. Okay. So that's the CGIAR, and CCAFS is, of course, the Climate Change, Agriculture, and Food Security Research Program of the CGIAR, with over 200 scientists working in 20 different countries. We do focus on research for development. So our overall mission is to deliver development outcomes. That's what we're most interested in. And I think each of you is doing research that contributes in some way to a development outcome related to food loss and waste. The CLIF program is specifically being supported by the low emissions development flagship of CCAFS. CCAFS has 4 different flagships, one focusing on adaptation, which we call the Climate Smart Technologies, Practices, and Portfolios flagship. Another one focusing on risk management related to climate and climate information services. The low emissions development program, as I mentioned, where you guys are housed, and then a 4th one on policies and institutions. So I thought I should just say a couple words about why we need better food loss and waste and mitigation data. One is that food loss and waste reduction is already something that's helping farmers and people in the supply chain increase their efficiency and productivity, for example, and being able to capture all of the benefits associated with that, including the emissions associated benefits with that, is a really nice way for justifying more intervention in food loss and waste. So just from the basic fact that we have improved productivity is already, and being able to quantify the emissions associated with that is a reason for doing this. But also climate finance. So for example, just yesterday, the Green Climate Fund approved several $1 million and has already approved several hundred, well, I have the actual statistics somewhere here, but not printed out, of course. So several $1 billion to support some 99 different projects around the world, and they're looking to verify the emissions associated with those projects. And so if we can say that food loss and waste reduces X number of emissions, that also helps some of these projects qualify for climate finance, which many countries are applying for in the name of what's called a NAMA, or a Nationally Appropriate Mitigation Action. Then we also have, of course, the participation in the UNFCCC and the nationally determined contributions to the Paris Agreement, and the global negotiations associated with the Paris Agreement, where people, again, want numbers, because countries are going to be reporting against their national targets for mitigation, and so they need to be able to quantify the contribution. So that is the overall rationale for better food loss and waste mitigation quantification. And finally, just wanted to say that we have some other food loss and waste work within the CCAFS program that I wanted to mention. We've just completed a series of business cases, and Jan is actually doing more related to different technologies, especially in sub-Saharan Africa, including the PICS bag, which tell you about the high levels of efficiency possible economically. We've done another study on USAID's portfolio and the reductions in food loss and waste in that agricultural portfolio of the Feed the Future program. And then Jan, who is pictured here again, has a overall program that's focused on developing a tool as well as strategies for food loss and waste, as well as business cases. So quite a comprehensive program. And he's going to introduce the calculator tool to you now. So I'll turn it over to Jan. Thank you.
Thank you, Lini. Can I get the access? Can I share my screen now? Yes. I think this should work. Do you see my screen? My PowerPoint slide?
Yes, it looks great.
Okay, thank you. So I'm going to tell you something about the calculator that we have developed, mainly within this CCAFS project. We call this calculator the H calculator, which stands for Agro-Chain Greenhouse Gas Emissions Calculator. And what is specific on this, there are many other, or there are quite a few other calculators or methods for assessing environmental impacts, and specifically also greenhouse gas emissions of food, of specific food supply chains. But many of these calculators only look at agricultural production phase, and we especially focus on the post-harvest part. That means everything from collecting the product to bringing it to the market or retail outlet, or you might even think of until the consumer. And because we work on interventions, so solutions for reducing food loss and waste in that phase of the food supply system. And we want to compare, we want to look at all the direct and indirect effects that might happen and that might affect the total greenhouse gas efficiency. And how we do that, I will show later. Our motivation to do this is, in the first place, we want to identify some hotspots. So identify which are the most important food loss and waste, which produce and where in a chain happen the most important food loss and waste. And also what is the associated greenhouse gas emissions connected to those losses. And furthermore, we want to estimate the benefit of the interventions. So does the reduction of a loss count significantly or completely, or preferably even is it much higher than the extra energy related or packaging related emissions that you will get? This slide also shows you a graph. This is just illustrating our work. We will publish it later, but it's part of this hotspot analysis. And here you see 8 columns. And the 8 columns are divided over 4 phases of the, 4 stages of the agricultural production or the supply chain. The first 2 bars are connected to the post-harvest handling and sometimes storage. Next is the phase of processing, where not all processes or products go through, but some products are being processed. Next, you have the phase of the food distribution, so that is mostly after processing, or some products are considered only in that stage. And then what is called here consumer is more the impacts that happen indeed at the consumer phase. So what the consumer is wasting, and this is these are very average data. Here you see called some categories of products. Wheat, which is globally an important crop, is identified as separately. And the same goes for bovine meat, or that is livestock meat. But there are also many products are categorized in collective groups. And for instance, we do have tomatoes, but we also have other vegetables. And this is the grouping according to Farostat. And we took the data by Farostat, and based on average values that I will show later, we have estimated the losses per product category in the different stages of this supply chain. And we've also estimated, based on our calculator, the greenhouse gas emissions allocated to those losses. And some typical examples here for Europe, you see that at the largest impactor in greenhouse gas effects, that are the columns with CO2 beneath, it's bovine meat. Whereas in the volume of the loss, it's only a very small factor. So these are typical observations that help us in identifying what product losses are most, or which product losses are most dominant in the greenhouse gas emissions allocated to the food losses. But yeah, okay, well, we use this in our work. It's also underlying the same calculator, but I will not further go into detail here, but maybe this is an indication for how you can work on the greenhouse gas emissions allocated, or greenhouse gas emissions due to food loss and waste in China. But I will now go further with our calculator. So as I said, we assess the net benefit of interventions. So we have a detailed, we need a detailed understanding, a description of what happens in the chain, in some reference chain and in a chain with some intervention, and make that kind of changes clear in our calculator. And I will show you now how we do that. We first formulate the chain configuration for a product, which might be a single food product. And I think that's also some of the one thing that you will be asked to do later when analyzing your chain and your intervention. We describe all operations along that chain that result in significant impact. And of course, that's the agricultural production phase. But in the post-harvest chain, then all activities that cost fuel, energy, packaging material, or that otherwise would be relevant. Next, we estimate the food loss and waste along that post-harvest chain. So for each operation, we use an estimate of the losses, and specifically we distinguish the first handling and storage operation. Then there might be some processing or packaging. Next, there may be another transportation stage, and after that, you can again have some cross-docking or processing or repackaging stage, and a food distribution chain. In each of these phases, we use an estimate of the losses that will occur there. And if we do a default analysis, we use secondary data there. And we have a complete set of secondary data that are at least applicable. I don't say they're very exact, because there's also in many groups there's a large variation, but at least there's some secondary data that we can start with in the analysis. And if we then insert the appropriate value in the calculator, we can this calculator estimates the greenhouse gas emissions related to those losses. And I will show you later how that works. And in our work, if we think of an intervention, then we first describe how the intervention will change the chain configuration. So what will be different? And that may be, for instance, the transportation frequency and thus the amount per load in the truck, or the storage durations, especially if you need refrigeration, you will need energy for extra storage time or less storage time, depends on the situation. Packaging material amount may be changed. There may be some other energy use, and hopefully, but that's another study, you will have lower food loss and waste values, and that you can all change in the calculator to calculate just the other scenario. And again, then this calculator will give the greenhouse gas emissions for that. One outcome of an example that we have been working on, this is about cassava processing. Cassava processing in different in traditional situations. That is, you see the two left bars in this graph, where you see the lower, the green part is the greenhouse gas emissions allocated to the agricultural production. Next, there is some waste, so you see partly a gray part in the first and the second bar allocated to losses. The yellow part is some processing energy use, and then blue bar stands for transporting this gari to a beer factory. But this product is not very ideal, so they would prefer to have another product like a cake or a flour. So we are in contact with a company who supplies a mobile processing unit, and with this processing unit, that's the third and the fourth bar in this graph. The cassava will be processed locally, and then the processed product will be carried to the factory. And again, you see the same amount of greenhouse gas associated with agricultural production. Then there is after the local processing, there is some. Oh no, there will be some collection transport from small farmer to this local or regionally located processing unit. Next, there are some emissions allocated to waste or losses, but this is much smaller than in the home processing unit, because the process is more efficient for technical reasons. There is some significant processing energy use. And next, there are also some emissions related to bringing the products to the central beer factory, which is the end user in this case. And that we compared with the situation of processing in a centralized factory. That is the fifth bar. And in the fifth bar, you see that there's a lot of there's a huge greenhouse gas emissions allocated to the collection transport, and also very large impact allocated to the losses, because a significant amount of the product gets wasted in the central factory. And there you see that the mobile system is much more effective. And we also made the comparison with imported maize, which has a very high emission in the agricultural production phase. We took the reference of imports from Australia, where they have some, for instance, some fertilizers used in agriculture, which require quite a large amount of energy. So in this analysis, we showed that if we want to make the good quality product, which is not the gari from the from the local processing, but the other ones, this mobile factory contributes to both reduction of food loss and a reduction of greenhouse gas emissions per kilogram of starch supplied to this factory. And I hope you can later also do something comparable with your case analysis. So what factors does this calculator take into consideration? In the first place, to start with, in the agricultural production, we look at the greenhouse gas emissions allocated to this crop. And this is predefined in our system. So you can, through a pull down menu, you can select a crop, and then you will get the default value. Next, there's the collection transport, and the impact included then is the fuel use. In processing, you can choose what kind of packaging material will be used. You can indicate how long a product will be stored, which leads to certain energy use. And also other energy use. I can imagine you will need some heat for product treatment or electricity. Then you can also select it. Next, there we have an option of transport. And again, the fuel will be the greenhouse gas emission impactor. Next, again, we have the option of choosing a second processing stage. Very often there's no processing or no significant processing, or only one processing step, but we have it in the model to make it more generically applicable. Again, you can choose a distribution transport, and then finally in the retail, there is some there may again be a significant energy use if you apply refrigeration. And furthermore, for each of these stages, we can fill in, or the system chooses default percentages for food loss and waste at that stage. And there is the option of also taking into account the waste processing of the product that is lost. And there it may be landfilling, composting, biogas, fermentation, or incineration. So as I already said before, we have quite a lot of default value in the model. So in principle, it could work standalone, but then of course it does not say a lot. But you can do a simulation without filling in a lot of specific data. To start with the greenhouse gas emissions to the crop production, we have used default data from Porter, who differentiated a large number of crop categories, and they also made the difference between the impacts in different global regions, and I will show later what regions they are. Next, for transport, we use some default value according to some LCA database, and they are differentiated for the truck type, so the load capacities, whether it's a small truck, or it can even be the delivery van, or a small truck, or large truck, or medium size. We have different types of ships, including containerized ships, and we have trains. I think I even have airplanes in this, but you better not try that because it has tremendous effects. Then packaging materials, we have data for paper or board, plastics, glass, and metal packaging materials. I think also aluminium is on the list. Next, for storage at different locations in the chain, we have energy use for, we have different values for large-scale storage in the supply chain and more small-scale refrigerated storage in the retail. Processing energy use, we have default value 0 because it's very situation specific, and if you have really significant processing, you may try to find some adequate data for your specific process from literature, or maybe you get it from directly from some stakeholders, I hope. And then finally, we have, as I said before, we have the food loss and waste per stage along the chain. We have again taken default data from Porter, who made a review of a huge number of food loss and waste studies. And again, like the greenhouse gas emissions allocated to the agricultural production, these data are differentiated on different crop categories and on global regions. Level of detail of these, so the data that Porter and some others have provided, that they distinguish 7 global regions, amongst with Sub-Saharan Africa, we have Latin America, we have South and Southeast Asia, industrialized Asia, etc. I can share which countries are in which region. I will show that, share that in the data I will share after this meeting. And you can see the overview of the product categories that we have in the system. We have a lot of crops. We have dedicated data, but for vegetables, we only, for each of these global regions, we only have one set of data for vegetables, for instance. So this is not easy to distinguish between, let's say, carrots or tomatoes, which is a bit sad, but I have some solution how you could deal with that later. So I think we now go to the calculator. You now see just a default user interface. I will go into the calculator now. It's this one. It's just in Excel, so we try to keep it simple. I will go through it, through some things, but I will assume that you will need some addition. You may have some additional questions, but we can do that later, maybe even offline. But I will start with the basics. I first go to the selection of the geographical production region, and here you can have a drop-down list, and I just chose here Sub-Saharan Africa. We have something similar for the region of consumption, and the reason that we distinguish these regions, so of the production and consumption, is we also want to analyze international trade. And for instance, if you would have trade from Sub-Saharan Africa, where you have relatively high loss and waste figures at the beginning of the chain, but lower, very small losses further in the chain, then part of the actions allocated to the close to the market will be in the export country system, whereas the production part is allocated to the production part, and the other one is at the consumption part. So after selecting countries, you are requested to press the confirm regions button, because then we fill specific worksheets with the relevant data. And next you can choose a crop, and that could be, for instance, it could be milk. But I think here it's easier to start with some. Well, let's say we choose the category of pulses, and then here below you see a list of activities along the chain. It starts with agricultural production, and you can this one I can unfold some parts. I will distribute a version of this calculator with everything unfolded. Here I just chose an initial unit. Mostly I take 1 kilogram, but you could also think of 1,000 kilogram of crops. And there is greenhouse gas, so CO2 impact of greenhouse gas emissions of 0.12 kilogram CO2 equivalents per kilogram harvested crop. In case you have access to some value which is more relevant for your crop, for whatever reason, somebody did an LCA for the specific crop in this production area, or you find a better value than only the average for pulses in sub-Saharan Africa, I could think you put here another value. Say it is 0.5. You can do that. You will not have the default value anymore, which may be a problem, but you can repair that in the system, because you can reset this, and then you can get the lookup function again, which takes the default value. So you're never destroying this Excel. You can also always get it back by just pressing the reset button. If you have significant energy use in this agricultural production phase that was not included in this greenhouse gas emission figure that you got for this crop, you can put in some other energy, for instance 1. And then you see on the right here that there's 1 megajoule of energy used. But mostly it will be 0, because an LCA of primary production does take that into account already. And I choose no losses, because this total CO2 impact is connected to the amount of this harvested. The next phase, at least how we described this, can be post-harvest handling and storage. And here you again have some fill-in fields. By the way, all the white fields can be user adapted, and the other ones are calculated, except for this initial value which you may choose. But other ones are all calculated based on the figures that you fill in. There are some relevant ones. For instance, the average number of days in a refrigerated storage, because refrigeration costs energy, and there's some greenhouse gas emissions allocated to that. I have 1 day here. I could say we have it 10 days in the storage, and then you will see that this value of the total energy use will be increased. So I changed 1 to 10 now, and you see that the total energy use on that line is going up, and this also counts for the CO2 emissions. Well, there may be some other energy use, but yeah, you can fill in how many megajoules per kilogram product you use. And there's an important value that is the loss percentage. Typically, according to Porter et al., the 8% of the crop on average is lost at this stage. Here I could change this if I have better data to 20%, but I will reset it. By the way, if you change this, you can look at these figures. So the total CO2 impact per change stage and the cumulative CO2 per kilogram product, which are now 0.028 and 0.15. If I increase the waste to 20, you see that these figures go significantly up because in the end the amount of products that end on the market will be lower, and all the impacts of the agricultural production will be allocated to a smaller amount of products. But I will reset this to the default 8. Then there's also the issue of the waste management for these losses. Very often this is taken out of consideration, but the wasted products may be used as for animal feed. Then commonly we leave it out of the analysis, but it may be it's very often landfilled, and landfilling has significant impacts or leads to significant greenhouse gas emissions. You see also a very high figure here of 64 kilogram CO2 equivalent connected to those 8% loss of 1,000 kilogram crop, and that the 0.16 or 7.17 cumulative that went up to 0.22. So also the waste handling is significant, may have significant impact. Next, collection transport. Here we used a distance of 50 kilometers. I just chose an arbitrary distance. It may be different in your situation. We assumed it was a medium-sized truck. It can also be small. It can be a train. It can be an inland cargo ship or a sea ship or a containerized ship, etc. So this is just, you can choose whatever you want. You can choose the most appropriate for your situation. And if there's refrigeration, you can also indicate that, because that will increase the fuel used by the truck. Next, there you can fill in. So there's an option of filling in some effects due to processing or packaging. Again, it's common to record the wastes over there, and here you see again a value of 8%. Could again look to this value on the right, the 58. It could be again be higher, say 20%. And then we see a significant impact due to the waste management. We chose landfilling, but it also affected the total efficiency of the chain again. But I will reset it again. Maybe most likely maybe landfilling, but could also be composting. And composting, if it is done well, provides some compost, which is fixing organic matter that can be applied in agriculture, and which is an effective way of taking out carbon dioxide from the from the atmosphere system, so it is associated with negative emissions. But for the time being, we leave it out of the analysis. Then you can indicate the packaging material use. So it could be steel packaging, or more likely plastic, or paper and board. You can fill in the data, and it will give some emissions. You see it here on the right. So you can fill it by yourself. And again, you can indicate the number of days that the product is stored in a refrigerated storage. Then there may be some international, transport, some further transport, maybe international transport, can be multimodal. So you can have first some transport in a truck, next some transport in a ship, and then again in a truck, or maybe you have different trucks, whatever. I don't mind, but it's for your use. And again, each time you can indicate whether it's ambient or refrigerated transport. Next, we have the distribution, and again, optional processing. And there's some things happening in the retail. Again, there you will have some losses. 2% is quite low. But obviously that is the recorded figure, but I could imagine that for many crops it's much higher, 14% for instance. Here we have combustion, but let's just leave it out of the analysis. Here you see that in the right column you see this cumulative CO2 per kilogram so the cumulative CO2 equivalents per kilogram crop, and that value goes dramatically up after this distribution transport to the to the buying by the consumer. And in this case, that is because we for this product we assumed it would be 5 days in a refrigerated storage, and this costs a lot of energy in general. So this has a very high impact. I can show you through putting this on 0. Then you will see that this value is almost equal to that value. So that is the calculator. Imported results are given here on top. So we have the total impact per kilogram crop, which in this case, so that is the total greenhouse gas impact per kilogram crop, which in this case is 0.215 kilogram per kilogram. But because we have losses, the total impact per kilogram sold in retail is higher, and that's in this case 0.263. And there you see that the losses have significantly contributed to the total impacts. And can I go up? What I also wanted to show here is that the total emissions allocated to that product here is significantly higher than the emissions allocated to only the crop production, showing that this post-harvest operation is significantly adding to the total emissions. And through this, I want to end this presentation. Any questions?
Hi, Jan. This is Juliana. No questions,
Yes.
but very interesting presentation, and I think all of us are excited to get to use the calculator. I think what we should do now, because we've been running around is have Norah present and then Tabitha present, and then we'll
Yes.
have some time for discussion, and
Yes.
maybe we'll shorten our break and we can come back to the calculator in that discussion.
Yes, very good. Thank you.
All right. So I'm going to change the presenter to Norah now.
Yes, I know.
And Norah, if you can show your PowerPoint, and also if you can turn on your video, that's great. And if not, that's also okay. Norah, please remember to unmute yourself. We can't hear you. Oh, it looks like it says it offline for Norah right now. So Tabitha, we'll have you go first, and maybe Norah have okay. So I'm going to switch you to I'm making you the presenter now, Tabitha, and then maybe Norah's had an internet connection and she can come back online.
Okay. Okay,
Yes.
can you see my slides?
Yes,
Are you
it
able to
looks
see my
great.
slides?
Yes.
Okay.
Thank you. Go ahead. It's just 3 minutes, so it's quick.
Yeah, hi everyone. I won't be able to use my video because my internet is not very reliable, but yeah. So I'm working with smallholder farmers, trying to understand the choices that they make after harvest. And some of the outcome variables that we're looking at, like maybe their storage choices, so the storage inventories, the purchases, their sales, as well as consumption. So those are like some of the relevant outcome variables that are like related to what we are discussing right now. So in terms of like the main issue that we are trying to look at, one of the major challenges that most smallholder farmers face is in terms of like storage is like the lack of efficient storage technologies. And so there's this phenomena that has been observed from like literature that most small-scale farmers sell immediately at harvest low prices, and then they buy back the same grain maybe later in the season during the lean season at a higher price, which is very costly for them. And so one of the reasons why they may be doing that is because they lack better technologies for storage. So since they don't have efficient technologies for storage, most of their grain is damaged. So they lose their grain, like in terms of quantity, the quantity of their grain as well as the quality. So that has implications in terms of like their food security as well as their incomes. Because if their quality is compromised or reduced during storage, it means they will lose their the money that they can make because the market value for the grain goes down. Not only that, when it comes to like say maize, which is mostly for consumption, the safety is also compromised as well, because the most popular method that they use in terms of storage is like acrylic combined with the ordinary bags, the ordinary woven bags. And so if they use that, usually they have like to use it to repeat the application like several times during the post-harvest period. And still during that period, they still lose most of their grain, and they also have aflatoxin contamination. So that also compromises the food safety issue. So those are some of the issues that we're looking at. So in terms of our experiment, we have like we have farmers in Malawi, and we're studying the farmers from Chinji and Lilongwe, focusing on the 4 major value chains. So maize, which is a staple food crop, soybean, groundnuts, and common beans, which are also like major cash crops for smallholder farmers. So in terms of the intervention itself, we introduced, like one of the intervention is introduction of the pig sparks to try and evaluate the effects that it will have in terms of like their storage, their consumption, as well as their marketing choices. So as you can see from the picture, so the traditional method that most farmers use right now is the woven bags and the chemicals like acrylic. And then now we are trying to introduce the pigs back to see what that will have in terms of the various outcomes that we're looking at. And so for the experiment itself, we have 4 treatment wings. So we have a control wing and some other treatments. So for the other treatments, we have like one wing that received the pig's bag, and then we have another wing that received the pig's bags, and also training for basic knowledge in terms of like finances and savings. And then we have another wing that was trained and also offered like credit. So for all those interventions, our goal is really to evaluate what that will have in terms of like, say, their post-harvest losses, their storage choices. So we have several outcomes, and amongst those we have like post-harvest losses, food security, expenditure on storage chemicals, as well as post-harvest labor. So really, the issue in this is to see what the impact of the pig's bag will be on like how much the farmers are losing, how much they're smoothing their consumption, like how much maybe the bag will have, what impact the bag will have in terms of their food security during the lean season. So yeah, in general, some of the issues that we're looking at are those. Yeah. I don't know if there are any questions.
Great, thank you, Tabitha. What we'll do is we'll try with Norah again, and then at the end, after the two of you, we'll go for questions and Jan can make some comments. So I'm going to try to make Norah the presenter again. Norah, why don't you unmute yourself and let us know if you can hear us.
All right, are you able to hear me?
Yes, perfectly.
Okay.
Great. And we can see your presentation. It's not in screen. You can go to slideshow or not. Yep. Excellent. Thank you.
All right. Thank you. I'm Norah, and I'm looking at the effects of amending soil with organic matter on the population change of Aspergillus flavus and its antagonistic microbiome, and also on aflatoxin contamination of groundnuts in Malawi. So basically, there is no sufficient documentation at present on how different sources and rates of organic soil amendments affect the population of aflatoxin producing fungi and their natural antagonists. And in addition to that, also the mitigation potential of these sources of organic matter in relation to their potential to reduce groundnut-based food that is lost to aflatoxins has not been explored. So basically, I'm trying to compare the effects of commercial organic fertilizer and farmyard manure on changes in population of Aspergillus flavus and its antagonistic microbiome. Here I chose Trichoderma fungi and Pseudomonas fluorescens, and also trying to evaluate the effects of organic matter soil amendments on the aflatoxin contamination in the groundnut. And also I'm trying to explore to compare the amounts of net carbon, net organic carbon that is returned by the soils amended with the farmyard manure and commercial organic fertilizer at varied rates. So what I did, I identified the pre-harvest period of the groundnut crop as actually the first critical point where aflatoxin contamination is inevitable. And I carried out experiments. I laid them out at 2 research stations in the central region of Malawi. So what I did was I had a randomized complete block design with 3 replications where I applied farmyard manure at the rates of 0, 2.5, 5, and 7 tons per hectare. And then I also applied commercial organic fertilizer at the rates 0, 0.2, 0.4, and 0.6 tons per hectare. On estimation of greenhouse gas emissions, I had quite a bit of a problem looking into this because I was expecting that I'll be able to measure the amount of emissions per plot, but such work has not been done here. The equipment is not available, so I'm thinking if I compare the amount of net carbon returned across treatments, maybe I could get something informative. But also this is subject to advice here. And as regards the food loss estimates, I'm going to do this qualitatively because I'm going to measure the amount of aflatoxins in the groundnut samples from each treatment, and then I'm going to compare that and see which treatments are giving results that give aflatoxins that are below the tolerable levels according to Malawi, that is 15 parts per billion. And also, potential food loss, I could estimate this by assessing the population change of Aspergillus flavus and its antagonistic microbiome to say if I find that the Aspergillus is increasing after applying a certain treatment, then I know there is a potential food loss there. Thank you.
Thank you. Thank you, both Norah and Tabitha, and also Jan. Jan, I don't know if you'd like to facilitate and make some comments or open up to questions. And I encourage everyone, as Lini said before, to please send your messages via the chat function or questions via the chat function, or just speak out. Go ahead, Jan. Yeah, Jan, we can't hear you. It shows that you're not muted, but for some reason we can't hear you. No. No, maybe take out your headphones. I don't know.
Better now?
Oh, there you go.
Yes. Oh, it was indeed on my phone, on my headphones. Sorry. I would like to add a few questions to both presentations because they were quite different and aiming at different things in a chain. To start with Tabitha's presentation, I think that's a very nice.
Yes.
This is a very nice intervention that you're looking at the pigs bags, and I clearly see that now you use the pigs bags, which is some material with also the bags have some plastic liners in there. You can easily indicate how much packaging material is being used per kilogram of crop. And I think in principle, of course, you will have to do some handwork, but you can very nicely try to how you could use this calculator for your work. I think we can discuss about that later. How do you look at that?
Sure. Sorry, I can't hear you, Kiri, but yeah. I just to make sure I got you right. So you're saying in terms of like quantifying the materials that the farmers in my experiment are using, I can easily quantify that, because in terms of the intervention, we gave out like 200 kilogram bags per farmer.
Yeah.
For all the farmers that were like treated.
Yeah. And
so yeah, I think it would be quite easy to quantify how much they're using.
Yes, but your challenge will be to assess what will be the loss in the traditional system and what will be the loss in the intervention after the intervention.
Yeah, actually, like one of the challenges that I've noticed in terms of like quantifying losses or estimating losses, like from our experiment, we actually get reported data from the farmers. Like we survey them, and then they, like for every 4 months, we follow up on them and survey them, asking them how much they lost. But then it's really subjective, because what they think they've lost depends on how they value like damaged grain.
Yes,
so
I know.
We use the standard. We use.
I recognize.
Yes. So we've been using that.
I read some studies about
Hello?
yes, do you hear me?
Yes, I can hear you. Yeah.
I read some studies about PICS bags use, and it's very difficult to get a singular value for the impacts on food loss and waste reduction, because there's, on one hand, there's the weight loss, on the other hand, there's the quality loss.
Quality loss, yes, yes.
Yes, so it's I think you are smart enough to think of some way how to show some net results on that. But I find
Yes.
it's very interesting that you now get primary data, because many of the publications on the PICS bags, they just compare the effects under laboratory situations with some with some added insects, and then it's I think it's not very representative for the practical situation.
Absolutely, absolutely. Yeah. So we have like an experiment that we have like the control group and like treated group. And then we're like going through them, like following up of them, like to get high frequency data on like several outcome variables. So amongst those outcome variables, we have like how much they've lost in terms of like them quantifying, like using the standards like World Bank measurements of like units for Malawi. So they quantify how much they've lost. Of course, it's like reported and subjective, but then we use that and like evaluate to see the impact, like comparing the control and the treated.
Yeah,
So
I
for
understand.
maize and groundnuts.
Yeah. Okay, thank you. Can I now have a short remark on Norah's presentation? Norah, are you here?
Yes, please.
I saw you have quite a challenge in estimating greenhouse gas emissions of your crop production.
Yes.
What you could do, and that is some simplification, because you deny all the organic matter in the soil. But what you could do is just add up the energy use for your the machinery, and also the embedded emissions allocated to the artificial fertilizer.
Okay.
And I'm not really focusing on agricultural production, so I don't know exactly, but there may be also some literature about greenhouse gas emissions, and that means differentiating all the different gases attributed to organic fertilizer types and also to synthetic fertilizers. And that in that case you could limit this greenhouse gas emission study to a theoretical analysis.
All right. But okay, in the application of the fertilizer as well as the manure, it was done manually. I did not use any machinery.
No, I thought so. Yes. Then
Yeah.
the synthetic fertilizer will have significant impact, because a lot of energy is used for binding the nitrogen.
Yeah.
So there are lots of data on that in literature. And I think for some typical animal manures, there have been some studies done on the greenhouse gas emissions due to those fertilizers, to those manures.
All right. And
So
in that.
I would recommend you to focus on that. And well, I am aware that the organic matter contribution to the soil is also relevant, but I have no solution for that. Maybe you can have a look at how others did that, but I think if you want to measure own data, that will be very, very complicated.
All right, then as you have advised, then maybe I would just look at it theoretically, look at what literature has to say about emissions from the associated sources of organic matter.
Yeah, thank you. I'm also very happy to see new direct measurement data, but I know it's very difficult, so I don't want to bother you with that.
Oh yeah.
Can I comment quickly though? You don't mind? Yeah,
Yes,
that's the comment
Lini?
to this Lini. I wanted to say, Norah, if you would like to support for measurement
You're very far away, Lini. We cannot hear you good.
in this, but please continue. I'll fix my audio.
Yeah, that sounds better already.
Okay, so Norah, if you would like support on the measurement of soil greenhouse gases, for example, using chamber methods, we certainly could discuss with you options for working through the CGIAR system and the labs, as well as some of the methods. So please feel free to get in touch with us about that. I think it should be possible. And then for Tabitha, I wanted to clarify, even if you are not doing greenhouse gas measurement, are you still assessing the greenhouse gas impact? Because that is the purpose of the grad study.
It's a bit hard to hear you.
It's not only a bit hard, I could not understand.
Tell me if that's better.
Rini, can you come back? I didn't really get what you said.
Yeah, is that better?
Yes,
Yes,
100%.
Okay,
Yes.
thank you. Yeah. So sorry about that. So my questions are related to, in the case of Norah, can we support you to do the greenhouse gas measurement? Because that is the core aspect of the Cliff Grads funding, is that we're trying to get better primary data on the greenhouse gas implications, specifically of, in this case, the food loss and waste reductions.
Okay.
So we're very, very happy to connect you to other people in the CGIAR. We can send samples to a lab. We can provide resources to you to help the analysis. So please feel free to follow up directly with me about that. And then Tabitha, I just wanted to clarify that you're doing some sort of greenhouse gas analysis on the PICS bags work. Thank you.
No, not really. But I'm doing something to estimate like the food loss or waste, like by comparing. Like so, like quarterly we have surveys with all the farmers that are in the experiment, trying to get like data on how much they've lost and how much of it has been damaged in terms of like quality and quantity, and then we're like comparing to sort of like see the impact of the pigs. So far we have data on like food loss, like post-harvest loss, but not on greenhouse gases. But with maybe assistance and help on like guidance on how to get that or how to estimate those, I can try to do something on that, because that will also be like really interesting to include in the experiment.
I think it would be super interesting, and we do have quite good data for at least, I think it's Tanzania and Ethiopia, possibly Kenya, on nitrogen-related emissions in maize systems. So we could probably help you also with at least some, default factors and estimates, even if you can't do any kind of measurement. So I'd love to follow up with you on that as well. And I just wanted to say, terrific presentations, both of you. Really, really well done.
Thank you.
Yes, I'm all. Thank you, Lini, for this edition. I also, as I said before, I would be very, very happy if we get some more data about the greenhouse gas emissions related to different manure systems, and also how the net effect would be if we take into consideration the losses in the post-harvest chain due to all the problems that that Norah described. And for Tabitha, I think it's our calculator is more or less ready for getting these things. And what is very often missing, especially if we talk about these PICS, is good primary data on the losses. So I'm very happy to hear this presentation.
Sure, I'm actually very interested in the calculator because
Yes, okay.
maybe just
we can discuss
maybe
that later.
I'll have like some follow-up questions. So
yes, I understand. Yes, I understand. We can contact on that. And I think if we have better primary data for your crops, then it's even getting more and more relevant. So we come back to that. Thank you. Juliana, can we now have a break?
Yeah. Yes, we can have a break, but I think we shouldn't take 10 minutes.
Yes,
I have
good.
17 after the hour. Let's just take 5 minutes.
Yes.
And start back at 22 after the hour. So everyone can mute yourselves. And then when we at 22 after the hour, we'll start with Li Shu's presentation. Thank you. Hi, everyone. That was a quick 5 minutes. I'm going to wait a few seconds and then we'll start up. You should be able to see, let's see, Li Shu's presentation.
Yeah. Hi, everyone. I'm Alicia. Can you hear me?
Yes, I can hear you very well. Please go ahead and start. Thank you.
Okay. Yeah. My research focuses on quantifying greenhouse gas emissions of agri-food chain and associated food loss and food waste in China. Hi, Julian. Next slide. Thank you. Okay. What are patterns and skills of food loss food waste along the whole Chinese food supply chain and the associated greenhouse gas emission? This is a research problem that we want to address. We aim to quantify the magnitude of greenhouse gas emissions induced by different food products and to identify the hot spots along the food supply chain with the highest emissions and to discuss greenhouse gas emissions mitigation strategies on the entire food supply chain. Next slide. Okay. The whole food supply chains related to 6 processes, including the production, post-harvest handling and storage, processing, distribution, retailing, and consumption. And we also consider the 2 markets, including raw food materials and the processed food products. We choose China as an example because China is the most populous country with 22% of the world total population, but only 7% of the world's arable land. And now the rural to urban migration and the increasing living standard lead to that structure change. Meanwhile, China is also experiencing a high level of loss and food waste. Now, some actions have taken to reduce the food loss and food waste in China. For example, the implementation of the 8 rules since 2012. Okay, next slide. Okay, thank you. As for the greenhouse gas emission accounting, we calculated it based on the emission factors and each stage for each category of food. In terms of the food loss and food waste estimates, we collected data. We collected the food loss and food waste data both from literature and the field study. The field study includes the consumer and the food supply chains. Okay, this is my presentation. Thank you.
Okay. Thank you, Li Shu. Now we'll have Xia Liang. Excellent, Xia. Thank you. We can see it well. You need to unmute your microphone.
Hello.
Now we can hear you. Great.
Thank you. How about the screen, the slides? Okay.
We can see it well. Thank you.
Hi, good morning and good afternoon, depends on where you are. My name is Xia Liang from the University of Melbourne. Actually, I'm at the final year of my PhD and plan to working on a stepping stone to the evidence-based for the mitigation of uncontrolled emission from reduced food loss and waste in China and Myanmar. Maybe a little bit overlap with Lixi's research as well. So my research problem and objectives I would like to know the potential for the mitigation of uncontrolled emission from reduced food loss and waste in China and Myanmar. So there are three research objectives. At the first step, I would like to develop a standardized methodology for estimating the total emission along the whole food supply chain for each major food categories, and then promote a national estimation of food loss and waste and total emission by integrating big data mining, meta-analysis, and process-based modeling in China and Myanmar, and then expand the evidence base for the mitigation of untold emission from reduced food loss and waste. So basically, I would like to explore the around like 155 crops and 11 livestock commodities, and the major category including all the cereal crops, oil crop, pulse, vegetable and melons, root tubes, sugar crop, fruit, tree nuts, and meat and milk from cattle, sheep, pigs, chickens. So so my research will be all the literature review and desktop research, no field work at all. So it will be focused on China and Myanmar as a case study. So currently, for China, there are some national policy and regulation relevant to food loss and food waste. Then can be categorized as two groups. Then one is address food waste generated, and another one is deal with food waste treatment by several government ministries and agencies. But for Myanmar, currently I haven't find any interventions for reducing food loss and waste. That will be my future task later. And for my research method, compared to other people's focus, my focus will be the agriculture and food commodities. So it will be all focused on the untold emission as well. Uh, Based on the life cycle assessment, ecosystem modeling, and process-based modeling, remote sensing, field monitoring, big data mining, and meta-analysis to establish the untold emissions factors for both China and Myanmar. And based on this, will combine with the life cycle assessment of the food loss, like pre-consumer stage and after consumer stage of the food waste. So basically, it's use the untold emission factors for each type of the agriculture communities that multiply the food loss and the food waste to estimate the untold emission. So this kind of I would like to establish the method and evidence based for this, and use China and Myanmar as an example. So currently, I have established the methodology, but still collecting the data for these two countries. So that's my research topic and the progress by now. Thank you.
Thank you so much, Xia Liang. Okay, we're going to move to Daniel. Danielle?
Hi, hello. Can you hear me?
Yes, very well. Thank you.
Okay.
We're just waiting to see your presentation, I think.
Okay.
Here you go.
You can see it now?
You see it. You want to put it in presenter mode, I think. Perfect. Go ahead.
Okay, good morning, everyone. My name is Daniele. I am from Brazil, from Federal University of Rio Grande do Sul. I am quite new in this area. I am from the business side. So my proposal is to understand the food waste reduction through entrepreneurship initiative and its associated impacts in Brazil, and to make a life cycle sustainability assessment. So the main idea is that when you think about food loss and food waste in relation to business, there is some market standards related to aesthetic issues of food mainly that causes some products to be rejected in retail. Although they have good quality and good safety for consumers. So aesthetic standards like weight, size, shape, and the appearance of food, they make mainly the producers to have a lot of food waste because they can't sell, they are not able to sell their products. So this research, the idea is to measure the food waste reduction and its associated sustainability impacts of Brazilian entrepreneurship initiatives in fruits and vegetables that do not meet retail aesthetic standards. There is new business in Brazil that they are rescuing this food and they are providing a second market for them. So the main idea is first to quantify this food that would be wasted and it's recovered to sell again. Second, to perform a life cycle assessment to identify the associated emission reductions. Third, to perform a social life cycle assessment, and then to perform a social return investment, which is mainly to the business area, and the idea is to combine both in the research. So we plan to analyze two supply chains from fruits and vegetables in Brazil. The biggest one in São Paulo, the smallest one is in the south of Brazil. But right now we are facing a cooperation problem because the company, the biggest one, first accepted to cooperate with us. And now that you are requesting the data, they are not answering anymore. So we are again in the negotiation phase, and we are thinking in a plan B to measure in the field in Brazil, but we are still working in this option. So the research methods is the first one, the main one is life cycle assessment, which I've been in Sweden with Professor Mattias Eriksson twice to learn the methodology. The last one was in April of this year. Also to make the social life cycle assessment and the social return on investment. And to estimate the food waste recovery, we plan to use the tree structure, which was a methodology developed by Mattias Eriksson, which is the university I'm cooperating, the Swedish University of Agricultural Sciences. So that's my presentation. So far, I've learned the methodology, and we are trying to collect the primary data with these companies and the producers and all the supply chain.
Thank you so much, Daniele. Go ahead, Jan.
Yes, to start with Lee, very nice presentation. I think you have a very nice focus looking for the hotspots of food loss and waste and greenhouse gas emissions in China. And I'm also happy to see that you are working on primary data, because there are many studies based on secondary data, and I hope that you can get more primary data. Many of the data that I have in our Western worlds is we have more uniform production systems and large-scale supply systems to the market. Must be very more diffuse in China. have you thought of how to address that?
Sorry, you mean the supply chain?
Yes, because some are very small, and you are supplying small villages, but also the big cities.
Now I'm doing the research as a whole for the Chinese for China. So now I don't separate it in detail.
Okay.
So
But
maybe now it's maybe in line with the classification by the FAO.
yeah.
Yeah.
Yeah, I will in my slides I will put in the reference to the paper by Porter, which I use for my data. They did a review on a lot of food loss and waste papers, and maybe you can use some of them. And FAO indeed gives totals for the food losses and waste, but they do not give details for the individual parts of the supply chain. And maybe through combining some with Porter's work, that is at least what we do, you get a first impression, and maybe you can improve that with your primary data.
Yeah. I collected data for the supply chain, for example, the production, the processing in industries.
Oh, very good, very impressive. I look forward to those outcomes.
Okay, thank you.
Thank you.
Okay, thank you.
Yes, thank you. Xia Liang, you
Yes.
are looking at mitigation options for nitrous oxygen oxide emissions. I have
Yeah.
I understood. Did I understood correctly that you also look at the effects of interventions?
Uh, yes. That's a plan. I think the first step I would like to do is try to estimate uh how much until emission during the food production chain for each type of food category. Then um then I would like to estimate the food loss and the waste for each category, then multiply the emission factor, then I can get how much actual emission by the food loss and waste. So that means the potential of the actual emission mitigation by reduced food loss and the waste. So I will do this scenario analysis by different inventions. Then I can do the scenario of the potential for each inventions.
I
That's a plan.
understand. That I
Mhm.
understand. Okay, thank you. I think this Porter paper that I mentioned, the sources they get it from, which are mostly more complete LCA analysis, they also might give you some details for this.
Sure, that'd be
Okay.
very helpful. Yeah.
Okay, thank you very much. Very
Thank
interesting.
you. Thank you so much.
And then I have some question for Daniele. You also show a very nice analysis of the impacts associated with the food loss and waste. And you are talking about secondary, secondary quality products, I would say. Could you also turn it around? You have some problems in getting some commitment from some companies, but would there be an opportunity of marketing it as a secondary class product? How do they look at that?
Sorry, can you repeat the end of the question?
You look at secondary quality products, or products that do not fulfill the aesthetic standards.
Yes.
I can imagine that this can be marketed on as a food product for at a reduced price or another market or whatever. Would there be some party interested in it?
Yeah, what was happening before these two companies entered in Brazil is that producers, they are just throwing away. We made a previous phase of this research, which visit like 15 producers, and you could see that they already knew that they were not able to sell these products, or it would be so cheap that it wouldn't work for them. So they just let it on field. And in Brazil, in the region of São Paulo, we identify a lot of food waste related to market standards, which this food doesn't go to market because producers know it doesn't worth to sell it. So these new companies, they are making fair prices, and they are working with high-income consumers, which they are kind of making a promotion, selling the idea that it's happening in the whole world now, which is nice to buy these food products, and consumers should pay better for this. So they are 1.5 years, they're selling these food products in Brazil. And we can see it's a large amount of food, but when you ask for this data regarding of which type of food products and that you want to visit the producers to know better, the company, they are kind of scared doing the research with us. So you are conversating again, you are negotiating to they enable us this data for us.
Yeah. But in my view, what you need is data about the extra effort required to collect this material.
Yes.
And then compare it to the emissions allocated to extra production.
Yes, this is what I'm trying to understand.
Yes, I understand. Yes.
But we need them to provide us access to supply chain behind them, and I think you are going to be able to do this because the negotiation is going further. But
okay,
yeah,
that's at least very interesting. I hope you will succeed on this.
Thank you.
And what I was in a situation a few years ago, and in that situation we met somebody who knew enough of the common production system and could supply us enough data so that we could still do our analysis. So he could explain how this chain was cooperating, how the parties were cooperating. He had some estimates of the secondary quality product percentage, and he could also give some indication of energy use and other things. So maybe you can find somebody who does know enough of it and can explain the details that you need.
Yeah, maybe I'll try to do that.
Okay,
Thanks for the suggestion.
Thank you very much.
Thank you.
Okay, Juliana, can we now finalize this discussion on all the research, or does anybody have additional questions or remarks?